Mm, okay, so hi everyone. Welcome. We're gonna discuss the chapter 7 from Devops for Data Science. And this chapter is about the cloud. So the learning I use I recycle a lot of the material from the last cohort. This time it actually matched the content. So and it's also it's gonna be a very short chapter. So I mean it wasn't hard or anything. Mm, okay, so as learning objectives, we have to recognize why you might or might not want to host services in the cloud. Differentiate between I, IS. I think I always said IIS. IIS. Yeah, but I guess it's supposed to be. Well, it's infrastructure as a service, platform as a service, and software as a service. That's easier. And then leads some common cloud services, and as the lab start and stop an EC2 instance on AWS. Mm, so this was a comment that was like there from the last cohort. It's quick section overview. So it says this section is really targeting the students who wants to host a project for portfolio purposes, the hobbyist who's hosting a toy project, or the data science leader who has no choice but to host things for themselves because they can get an IT or an admin support. And I mean, they're completely right. The cloud might not be for everyone, but we like I guess we all gonna use some of their services at some point. Mm, okay, so I don't think that the cloud needs that much of an introduction these days. Maybe like 10 years ago, or yeah, 10 years ago it needed. But now, like, we all know that the cloud is just like rental servers. We know that I mean AWS is the kind of like the biggest player, but also Google Cloud and Azure. Although I'm like I don't know, I don't know that many people who uses Azure. Actually, just a comment when I was finishing college. That was like 2012. We had a project, and like in that class we actually had like a real client, and there was this accountant from Cuernavaca, like it's near Mexico City, and he wanted to develop a tool for his clients, and he was like, but I want to use Azure. And I always thought that like he was a visionary because he was like 2012, like no one was using the cloud at that time, and he really wanted to use Azure. So we developed an app for Azure. Then we didn't maintain it that much, and it eventually died. But I mean, yeah, now it's common. I mean, the cloud doesn't need an introduction. Why someone would like to like go to the cloud? Because of flexibility. You can scale up and down as much as you need, and you also don't need to manage hardware. You don't need to have an IT admin, uh, and you don't need to care about, yeah, about like the actual machines, about setting a room for your servers, about like having all of the infrastructure and the cables and everything. mm, and I mean that was the case before the cloud for every organization, every company, every institution, and years ago. In I mean it has its benefits, as the chapter mentioned. It was it was I guess they were trying to sell it as, oh, it's gonna be like so much cheaper, because if you don't use the server, you'll be able to like turn it off at night, and then just like turn just the exact amount of services that your users are needed, and that's not easy. And I mean, AWS and Google, like they know how to tweak their services so that you're not actually saving that much money. I mean, like Jeff Bezos is Jeff Bezos for something, right? But yeah, I guess like all the promises that the cloud had, they they didn't materialize completely, and now people are like going back to actually having servers. mm, in Mexico, the institute, like the way the government gives money to the institutions, it makes it really hard to use the cloud for computing, because like you get money for a project for a certain amount of time, and then that money is gonna be gone. So you're better just buying a server with that money and figure it out how to set it up, and how to, like, yeah, maybe get an IT, or just like make one of your students learn how to do like the minimum enough to actually some Linux administration, because then your money is gonna be gone, and like you won't be able to commit to like a big timeline to actually use the servers. So yeah, I don't think that the cloud it's a thing for institutions in Mexico. Like for universities and research institutions, government research institutions. And actually, like that's how the place where I did my PhD is at National Institute of Health. We have the servers there, and we were hacked some months ago. Someone was mining bitcoins, and yeah, now I can access any of the data from my PhD project. So yeah. I don't know if you have any comment on this. Like, do your institutions, like, do they use cloud services, or uh, or are you on physical servers? And I guess like many of the institutions have some kind of a mix.
Yeah, definitely a mix, although I feel like we're shifting more towards platform as a service. I have mixed feelings about that, though I'm not very expert in that area.
Okay. And which platform, like, do they use, or
All of them.
all of them? Okay.
Yeah, so we have AWS, Azure. Although actually I shouldn't say all of them. I don't know that we have Google Cloud. I don't know that we use Google Cloud. Um, and then other stuff like so platform as a service. I guess this would qualify as platform as a service is Databricks.
Mm,
Um, I think is the thing I've heard about most recently. Those are the big ones I'm aware of. Yeah.
yeah. Yeah. Mm,
And then of course we have our on-prem stuff as well, the physical servers.
yeah. Okay, so we're gonna review the infrastructure as a service and platform as a service. So infrastructure as a service was like the first thing is where you rent a server, and you're actually like you're not renting an entire machine. You're renting a virtual machine, which is a virtualized server on a virtual machine, and they're called instances. I guess all of the like cloud, Azure, and AWS call them instances. Mm, and that's gonna be like that's gonna be your machine. Like that's gonna be your server. You will be able to SSH to that instance. You will be able to like run different operating systems. Like you can select the operating system when you actually create the instance, and it's gonna look as if you had a server somewhere, like a physical server that you're like getting into, that you're connecting to. There's also another kind of instances, and like then I wanted to share like how we use Google Cloud at Dana-Farber, which is like my work right now. Mm, and these are the kinds of instances we use. We use spot instances, and these ones are stateless for stateless and fault tolerant applications. So these are instances that are gonna just like live for a short amount of time. They're gonna just do one task and then they're gonna die. And they're cheaper because what Google or AWS is doing is that they're renting you the space that no one else wants. So I mean, it's a space that no one else is using, so it's gonna be cheaper. But that also means that at any time they want, they can take the machine back. So that's why you have to like you have to use them for fault tolerant application, something that you can just like start all over again, because you don't know if your task is actually gonna finish successfully. So yeah, those are cool spot instances, and they are cheaper. You don't have a machine that is always running. You just use it for for one task. Then we have platform as a service, and in this case, like they manage the service and your applications. So what you get with the PAS thing, you get a ready to use environment when you can deploy it and test and manage your applications. As example, we have the blob storage, the lambdas. I think like they're called lambdas in AWS, and I think in the other services are called functions. And when I started working at Thermo Fisher, lambdas were starting to be like a really big thing, and those were they're called serverless, but nothing is actually serverless because it has to run somewhere. So yeah, but the thing is that with the lambda, you just have uh like a function that is gonna be called through an API, and when you hit that API, the lambda runs, it returns the result, and that's it. So it's kind of like in that sense, it's kind of similar to the spots instances, but like here you don't even have like uh you don't even have machine specific specification. Like you don't have anything because it's supposed to be serverless, but of course it has to run somewhere. And and another example is all of the services related to container orchestration, and all of the Kubernetes different flavors. And I added Posit Connect Cloud here because like I guess that's a platform as a service, right? Mm, or R Studio Cloud, or the Shiny. I don't remember what it's called. Well, I
Shiny
guess now
server?
Shiny server. Yeah, thank you. I guess now they're all in Posit Connect Cloud, but yeah, I don't know if you have used them. If you have used R.
Um, I don't think I've really used them, but I actually have a couple questions for my own understanding about some stuff on this slide. One is just like super basic Lambda functions. Those are like, I think those are something more used in or named in Python. Like, I don't know if R really calls them
Uh,
Lambda functions. Like, is this
I
a programming concept or like a way to write functions, or is this a type of service?
it is a type of server service. In the mm, so yeah, it is a type of service. It's called Lambda in AWS, and I guess Azure also calls it. Azure calls it container apps
Okay.
or function, or and yeah, container apps or functions, and then Google Cloud calls them cloud function. So what they mean
Oh, okay.
by that is, uh,
I think I was getting confused because I just had to Google this on a separate screen, but I think Python calls like an anonymous function a
yeah,
Lambda function.
yes, yes,
Okay,
yeah, yeah,
okay.
yeah,
I think that was
yeah.
my confusion.
Yeah, no, you're completely right on that, and just AWS, they choose that for their naming, and it is like, yeah, you have a function associated to an API URL, and you assign that to this service, and then like when you hit the API, it runs that function.
Gotcha. Um, I feel like I might be getting overly pedantic, but like Lambda, like the word Lambda, I don't really think of anything other than the Greek symbol. Like, does the name Lambda carry any like inherent meaning to you besides like
I
just
don't,
an English
I don't
spelling
think
of the Greek letter?
I don't think it does.
Okay. I was trying to like intuit some sort of
Yeah,
meaning
no.
from it, but
Yeah, no, no. I don't know. Does anyone else have uh
Maybe there's more to it, Josh, but I would think it's kind of like what Diana was saying earlier is like, the cloud providers, they have to name their products things, and
mhm.
sometimes or jargon arises and it doesn't even mean the thing that it seems to mean. Like serverless is not serverless, right?
Yep,
It's some word that means something, but not like what the term means in plain English. Yeah.
yeah.
totally. I
Maybe
think I like that tracks well for like for-profit cloud providers, but like why does Python use Lambda? Like
Yeah.
why do they choose Lambda as opposed to like the Omega function or the beta function? Maybe beta is a linear modeling thing, but
maybe in our world, lambda is something you don't have to name it. It's a proxy. There's like you can have that function name, but you just have a lambda or a tilde over there and just use it without the name. So serverless
Yes.
without the names.
Yeah, yeah, like a yes, and like an anonymous function, right?
Anonymous. Yeah.
Yeah.
mhm,
Thank you. Anonymous is something that is there might be that might be. I don't know. It's my just thought of it.
gotcha.
Yeah.
I just wasn't sure if there was some sort of convention for like why Lambda, but
Yeah.
uh, my second question is actually more related to, I guess, not pedantic etymology of words, but what do you all use like as your in your data analyst, data scientist role? Like, how do you get data from your organization? Like, where is your organization's data stored? Is it in blob storage where it's like flat files? Are you querying SQL? Are you getting it from email? Um, like I to
Yeah.
maybe start like we don't use blob storage where I work,
Right.
so I'm like intrigued by it. It sounds like an attractive solution to just store binary large objects, like rectangular data files that don't really have like a SQL structure. But um, curious to see if anyone uses blob storage and like is a big fan, or if they don't like them. If anyone wants to share.
Hmm. Right. Yeah, I can share, but I wanted to share kind of like the whole ecosystem, but yeah, I can do that just like in 2 minutes. Hmm.
Okay.
So wait, George, so you have, yeah, how do you share your data? Like you have files, and then
Um, we have something called Cognos, which is an IBM tool
okay.
that it's like a GUI, a web page where you can like choose columns and like make a table by dragging columns into like a table format. But
Okay.
what's being done under the hood is like SQL code is being written.
Okay.
Um, but I have like, as a data analyst
Hmm.
type of person, I have like qualms with that because you can only download like 1 million rows per
Okay.
table, and then you have to like add filters to like by time to like, just give me this chunk of time, and it's also like not very fun for reproducibility because I can't like in code point to an object on blob storage or query a warehouse through SQL. But yeah, was
Will
just
that,
curious if
yeah, I have a question that, like, will that fall into software as a service, like Cognos? Because
I think so. I'm not very educated on the fine boundaries between like software as a service, platform as a service, and all the other as a service offerings. But if nothing's jumping out to anyone, that's totally okay. We can move on, and I don't mean to waylay the conversation.
no, thank you. Yeah, I don't know if anyone wants to share. Like, I will share it, but just once we're done with the server, with the software as a service.
Yeah, I would say like just for me, like, briefly, I think data are stored in lots of different places for my team. It's maybe more like shared by email, not literally by email, but it's kind of on the lower tech side.
Yeah.
Because we'll work on like ad hoc projects where it doesn't make sense to set up this infrastructure just for that thing, and everything's a bit bespoke. But I'm very intrigued by S3. I really want to find the time to learn more about that in the future because it seems like that would be a nice compromise between something modern and more reliable, um, and not unduly difficult to set up. Yeah.
Yeah,
Okay.
no, totally. S3 is great. Like, even as a personal storage. Like, yeah, I used to use it like to save kind of like some results from my project, and just like as a backup. Then I deleted it, and then the hacking happened, so I shouldn't have deleted it because I was like, no, I'm never gonna use it, and I was paying, like I was paying out of my money, and yeah. So, but like it's very, as you said, Arthur, it's very easy to configure, and it works, and you have like all of your data right there. Okay, so so the final thing is software as a service, and this one is like, I mean, now we need a subscription for everything, right? And it is easy to like to think of different examples for software as a service, software as a service applications. Because for instance, yeah, content management system, like the all of the different ways that people can write blogs, that's software that is right there, and you just subscribe to it, and then like if you want to have a blog, you just create one, and you don't have to worry of like where is that piece of text store, or you don't have to worry about like anything. Also, like for project management, all of the tools, like, damn, I forgot the name of those, but the Atlassian suite, and yeah, all of those. Mm, and yeah, there are like tons of different examples. I like when I was like reading this part of the chapter, and I was looking into like some into getting some more information. The data as a service thing came up, and that was something that I hadn't like thought about. And now that George mentioned the Cognos IBM, I guess that will fold into software as a service. Sorry, data as a service. Also, like Snowflake and the other one, and Databricks. I'm not sure. I guess that. Mm, I feel like the lines are a little bit blurrier in those, like for those type of softwares. Because like what would you consider data as a service? Like you have a platform where you store the data and yeah, you can query it and
I would
yeah.
think like maybe this is like a Bloomberg terminal or something if you're working in finance where the actual stream of data or the product you get. And one of my friends worked at a company where they kind of took I don't know which verticals, what industries they serve, but I think they tried to handle the data engineering part for people and just kind of like ingest the raw data and provide a reliable stream of data for consumers. I don't know. To my mind, that might have been data as a service, but
Mhm.
I don't know if that's what's meant here, or if it's like storing the, yeah, I don't know. I'll stop there. I'm a bit confused about this as well, but also it's because I've heard of Snowflake before, I've heard of Databricks before, but I don't quite know what they do.
Yeah, yeah, me neither. And yes, and I guess they're used yeah, they're used for more of the business intelligence yeah, platform and applications. But I think I will consider this as data as a service.
Yeah, someone
Mm,
mentioned Databricks to me yesterday actually, and I was kind of looking into it, and it seems like perhaps it does more than this, but it seems like it helps with some of the orchestration functions. Like let's say you have a bunch of jobs and they need to run, there are dependencies between the jobs and you need to orchestrate that. I mean, you could do that with other tools, but then they, I guess, take the headache out of it, I think is the sales pitch. I don't know if other people know more about that. And then for that, it kind of feels like it's more, I don't know, it sits somewhere, like you're saying, Diana, like the lines are really blurry now. In my mind, it sits somewhere in between platform as a service and software as a service. It feels like it has elements of each, and I think that's probably what the vendors are probably doing is like they have, great ability to upsell you for, new features. Like once you buy into their platform, then they can sell software that becomes something upon which you rely over.
yes, yes, yes. You're completely right, Arthur, and I agree. Because at first I thought it was platform as a service, and then like I did a little bit more digging, and they were saying like, oh no, it's software as a service. So yeah, the lines are blurry, and I'm not even sure if it is actually a thing. Like I guess that now with AI and yeah, with AI application, it's gonna be bigger every day. So okay, and finally we have here some of the common cloud services. Yeah, the Kubernetes cluster, and there are different names. The Lambda, Azure functions, and Google Cloud Functions to just run a function as an API. Databases, they also like they all provide different different flavors of databases. And now I guess they also have machine learning platforms, and they all give you a way to control access to the applications and like to all of the other services, and yeah, they have their own service to actually do that. Mm, and now I don't know what will, like, what do you want to do? Like, do you want us to go to the lab? Like, did you do the lab and you have some comments, or do you think you will actually use it? Because if not, I will be glad to share what we do. If that's fine with you, I can share how we use the cloud
Super
in
interesting, yeah.
Yeah, I'd be keen to see that too.
oh, okay, nice. So we use this service that it's called Terra. This is, I guess, we'll call it platform as a service. This one is from the Broad Institute. So it's something that the Broad Institute built, some years ago, and like everyone at the Broad Institute uses Terra, and it's also easier for us because when we do the sequencing of the samples, we do it also with the Broad Institute, and then they will deposit the data right there, so we have everything right there. And so if we sign, mm, I mean, it's nice, but mm, it's nice, but it's not like it's not super great. It has its flaws, and now that a lot of people are getting laid off from the data science platform, they're gonna partner with another company that's called Manifold that adds like an AI layers to like the same thing, so it's gonna be more interesting. So sorry, Terra it has workspaces, and each workspace is associated with a cloud project, with a Google Cloud project. So everything we do here will be attached to an account and like to all of the Google Cloud services. They also let you use Azure, and once they move to Manifold, they will be able to also you will be able to use AWS too. So we have we have tables associated with each workspace, and because many of like it's used mostly for yeah, for clinical projects and projects associated with biology. So they decided that there were like all of your workspaces will have these tables: sample, participant, and pairs. You can also build your own table. So I guess someone who's not doing like biology science will be able to use it, but that's what they thought as a default. So yeah, and these are like tables, normal tables as like in any other database. So yeah, we have our samples, and these are all of the different columns associated with my samples, and I can download this as a TSV file if I want to use things offline. They also they have these analysis things, and now you can run Jupyter notebooks or RStudio notebooks right here, so that you don't have to download your data and do it offline. And like for instance, this is a table, but some columns of these tables are associated with files. For instance, this one. So this one is a PCOB file. That one I don't know what it is, and this one it's actually storage in like inside Google Cloud. So if I wanna get this specific file, I can just like run this command to copy from the cloud storage into my computer. So we have the tables, but we have the blob storage like in the back. And yeah, something that we use a lot in computational biology is like the MAF file. Those are associated with mutations in a sample. So again, we have like this file, and it is storage in Google Cloud. Now, for our workflows, we use Weedles, and this is the WDL programming. Well, I don't know if we call it a programming language, and I always forget what it stands. It's workflow development language or workflow something language. So it's kind of like it's similar to targets and to a snake make. You have different tasks, and yeah, you have different tasks. You have your input, you have your output, and you're gonna be like connecting this task through the file that you're gonna output for each task. So this is a yeah, one WDL file, and each task runs an specific command. Sometimes like you have, yeah, like bash inside the task, and then some runs with Python files, but it is also associated to a Docker image. So we have to set up a Docker image, and then the WDL is gonna call this Docker image to run this task. And for instance, this Docker image is hosted in one of the other services that the book doesn't mention. It's called, I don't know the name in AWS, but in Google Cloud it's called Artifact Registry. That it is similar as a Docker store, but yeah, it's the same thing as Docker store, but for Google. So yeah, or works or workflows will be calling multiple Docker images, and each Docker image will run a specific task. Then when we actually run the workflow, for instance, I have here the submission history. That Docker image is gonna run in a specific virtual machine in Google, well, in Google Cloud. So I have to go to the job manager. These are all the different tasks in my workflow, and then if I go here to go to the backend log, these are all the jobs that are associated to those tasks in my WDL. So all of these are different tasks that run in one of these spot instances that I mentioned. So what Terra does is, for each task, it will request a spot instance in Google Cloud, and it's gonna run that specific Docker image in that spot instance. So sometimes the task failed, or sometimes Google reclaims those instances, and the task died. So I mean, Terra, what they do as the platform is orchestrate all of this. Like, I don't have to worry about turning on and off all those system instances or requesting all of these instances. I just have to write my WDL, set up the different Docker images, and then like just run the workflow, and Terra, like the service that they offer as a platform, they will do all of the like the backend job of asking for those instances and setting up the instances, and telling Google that I want to run those tasks in those instances. So yeah, I guess this is another service. It's called like Google Batch, and that's where they let you like run multiple, like, yeah, multiple instances associated to one specific job. and yeah, and like at the end, each of my results, they're always stored in a specific bucket, and what my table has is links to these buckets. Mm, and this is kind of like, this is how we use Google Cloud. I don't know if
This
I don't
is
know if
super
I.
fascinating. Yeah, I've not touched any of this yet, but one thing that kept coming to mind is watching you present and hearing you talk about this is where do you where do you actually do the development? So do you kind of develop in on the platform because or do you develop locally? Because I would feel like I don't know. For me, I'm comfortable developing locally. But at the same time, things that work on my machine may not work in the platform because of specific things about the platform, like permissions issues, or like maybe the file system is different on the platform than on my machine, etc. Yeah, just curious
Yes.
about that.
Yeah, no, totally. So the development, like I do it, or I mean, we all do it locally, and what we're actually developing is what is inside the Docker images, like all of these, yeah, all of these, in this case Python scripts, and like this code in Bash. You set up your scripts that are gonna do a specific analysis. Then you wrap those scripts into a Docker image. You upload your Docker image to the registry, and then, and like you kind of do testing, but not yeah, like I can test my scripts maybe with one or two samples locally, and then I upload the Docker image. I put it into the registry. I set up this whittle if I'm gonna be like doing multiple tasks, like one after the other, and then like the part where I would like to run this in all of the, I don't know, for in, well, this workspace is very small, but because it's just a testing workspace. But the part where I have to run like the same analysis on 600 samples, that's what is gonna be run in Terra.
Very cool. And
Mhm.
so I take it like you do, like maybe thinking back to a couple presentations ago, like how do you have like a dev kind of like workspace, like versus prod, like dev workspace? Like let's say, you've got it working on your machine with one sample, you've pulled down the Docker container, everything works, but you're wondering about like the orchestration, like is your WDL file cool? Do you have how would you go about like testing that? Is there like specific workspace, or is it's just a job like any other job, and you know the ID of that job, and you kind of look at the outcome. I'm kind of curious.
Yeah, no. Yes, like sometimes, like in this case, for instance, all of these tags succeeded, but this one failed. Yeah, I don't do that much testing in like locally. I will just test that my scripts work, but then it might, like, for some reasons it might not work for some of the samples. In our specific case, it always happens, like the jobs always fail when we have a low quality sample, but that I don't see it until the job has failed, and I look at the logs, and then I can like go back and say, oh, like, yeah, this was a low quality sample. Hmm. But that, I guess, it's for the nature of the project. But
But I mean, I guess for the orchestration part, that's not.
yeah, for the
I mean, I guess
orchestration,
that's the appeal of the platform is it's not something that you would need to test necessarily
exactly. Yeah,
or as much.
yes, no, exactly. The orchestration part is what Terra does for us. Like, I'm gonna switch to a different workspace. For instance, this one, yeah, like I run 180 things like at once using the same width, using like the same description. And in this case, there was something wrong like from the beginning because tons of them fail. So all of this orchestration and setting like the different the different buckets for each of the tasks associated to the samples, and like setting all of the execution directories, and that's something that I don't have to do because that's the service that Terra offers.
Whether you, Diane, or others, is anyone at a previous job kind of done this the manual way? I mean, I can imagine that you could have like a make script or something like that that would do this. And I'm kind of divided. And maybe this is just like a principled level, I suppose. Is like, is it really worth paying for these platforms? I can see definitely the advantages, but I can imagine the platform costs can probably be high, and the platforms are not going to be without their own rough edges too. Yeah.
Yeah, I will say that maybe it's not like it's not worth it for personal projects or for things that are not this big. Yeah, sorry, Josh.
Oh, I've kind of been drifting in and out of the conversation as I tackle some work priorities on the side, but I think in case it's helpful, I'll say that I've been using targets to orchestrate things written in R, and cron jobs to like run that pipeline locally on my local computer daily, whenever like my computer is on during the workday. Not sure if that's totally relevant to this because I was kind of drifting in and out, but thought I'd mention it in the off chance it's helpful.
Yeah, that was exactly what I kind of had in my mind, Josh, is like, you
Okay.
instead of on your own machine, maybe you could get a compute instance and just run it on run something like that on the cloud instead of doing this orchestration stuff. Or sorry, instead of using like the platforms. Um, I don't know, maybe I should just dive into a platform and try it out. I'm a little scared that I'll like it too much.
And there goes all your money.
Yes, and there
Exactly. I
goes.
mean, it'd be where I work, it'd be their money, but
Yeah,
still.
Yeah.
Sure.
Yeah,
Um,
what I
sorry, go ahead.
what I do like for my for I haven't used Target, but I use Snake Make, and yeah, like same things. Some of the tasks with Docker images, some of the like some of the tasks just with different scripts like right there. But that's because I haven't learned how to like use targets. And and the orchestration with the snake make is not that big of a deal. Like you just write your scripts, you set the rules, and you just run the entire thing. And that, like, maybe you could run that having your data in S3, and making sure that each of your scripts will pull that data from S3, and then like do the kind of the downstream analysis. Like that's something that might work, but still running it in your own machine if it's not like something super heavy, or in a different server if you already have that. Mm.
Diana, just out of curiosity, I guess maybe as context, I'm an R user mostly. I'm a big fan of targets. I've tried to adopt Python more in my own work, but I'm not sure what pipeline orchestration tool is like most common. I've heard of SnakeMake. I've heard of PyTask as well. Um, have you used both and you prefer SnakeMake over PyTask, or just looking for
I
insights, I guess?
No, I've never used PyTask. I've only used SnakeMake, and it's.
Okay.
I mean, it was easy to learn. I've heard that it doesn't look that much. That is not that similar to targets, but it's not hard either.
Okay. I think that's what I've heard too, that PyTask is maybe more similar to
Mm.
targets. But if you like aren't coming with the targets mental model, SnakeMake is like robust, well made, widely adopted software.
Yeah.
My, I guess, related question is, you were using Weedle, the WDL, for like
Yes.
pipeline orchestration, which is totally new to me. I've never heard of it. What is the the like niche that Weedle fills? Like when I think of maybe language agnostic workflow orchestration, I think of like GNU make. But like, is Weedle an improvement on that, or does it do something different? Is it only used in Terra?
No, it is. I think Whittle is older than SnakeMake.
Okay, but it's
Yeah.
not Python specific.
No,
It's
no, no,
meant to
no.
be.
It's yes, it is language agnostic, and yeah, I think that this one is old. I don't love it. The documentation is not great, and it has some like weird ways to do
Okay,
things. Another one
gotcha.
that it's really popular, and it's getting more popular every day is Nextflow. I really want to learn
Okay,
Nextflow.
interesting.
It is similar to Widows. It's like this one is backed by this company. It's called
Okay,
Sequera, and it looks like the community is like it's big. The documentation is good, and yeah, like this could be another good one.
okay, interesting.
Mhm.
Thanks. I'll keep that in my back pocket.
Yeah.
Two that came up on my radar recently as I was kind of having a conversation with my favorite LLM was a Prefect and Dagster. I'm wondering if anyone has used those. They're kind of billed as um, language agnostic orchestration tools, and it's unclear to me whether they're tools or they're services. I didn't know if anyone had used them or heard of them.
I've heard of Dagster, but no lived experience with it.
No, I haven't heard of the Dagster.
It's like a directed acyclic graph
Okay.
stir.
Mm,
Um,
okay.
Arthur, maybe if you could like broaden my worldview, what is your reason for using or being interested possibly in Dagster? Like, is it to orchestrate a pipeline that uses more languages than R, or like what's
Yeah,
the
exactly.
niche?
I've
Okay,
got so I work with household survey data, and we're thinking about a little experiment in the sense of kind of try something and see what happens, where we would maybe try to capture the audio of the interviews and then use a speech to text transcription model in Python.
hmm okay,
But then a lot of the other, let's say, more analytics for the micro data, the answers to actual survey questions, it's easier in R because I've written some stuff to do that. So there I'd have to kind of orchestrate the two things, and um, I was looking a little bit for something like that. I haven't made the
sure.
leap into targets. I really should. I don't know what's held me back, but I really want to learn targets. Um, but this is kind of a use case where I'm not yet a Python person. I aspire to be one day. But where
Ditto.
this like speech to text transcription, I think there's no real analog to that in the R world. I think there's a wrapper for Whisper, but in our case, we probably need some Hugging Face transform, like some models that don't yet have R wrappers. Yeah.
Okay. Cool. Yeah, I'm gonna look more into Dexter's. And I guess it's always good to have like all these different tools like in as skills. Yeah, I want to learn targets, and SnakeMake works well with Dart scripts too. It's been a nightmare to use it with the RM. I can make it work, but I'm sure I'm doing something wrong. But yeah, like I mean, it's good, and I feel like once you start using them and like you kind of like you push yourself to use them like every time you set up a new project, then it becomes easy and it's good.
Are there any, like I'm aware of GNU Make. I think if Olivier were here, I think he'd be able to speak about that a bit more intelligently. But every time I encounter it, I also hear people talking about how esoteric the flags are and difficult the syntax is, et cetera, et cetera. So it feels like they're rough edges. I was wondering if anyone is aware of any kind of more modern make. 'Cause I really like the idea of using something open source that's language agnostic, but at the same time, hopefully is more approachable than make appears to be.
I thought that was like what Dagster was trying to do. Again, I might not have any, I don't have any real lived experience with Dagster, but I thought it was language agnostic, and it's open source. So that's where I would
Oh,
look.
it
But
is open
I'm
source. Okay. The flashy website gave me pause. I thought it was a service trying to sell me
like
something.
It's really nice.
like I speak like I actually know what I'm talking about. I assumed because it has like a GitHub page that it's open source, but you know, I would say don't trust me.
Yeah, no, I have no idea, like, and something, yeah, something else, other than make, and I guess, like, yeah, I've written some make scripts. If you don't use it for like very complicated tasks, it's fine and it's not that hard. Yep.
Challenge accepted.
Nice. So I guess we should end here. If anyone has,
That sounds
uh,
good to me. Thanks so much for the presentation, Diana.
no, thank you so much. Yeah, so I guess we'll see you next week.
So the question, is it end or is it stop that we
Oh,
have to write, or does it matter?